I've been telling you, the Caribbean is a ticking time bomb, and now the atmospheric ingredients are beginning to align. We could be looking at a named storm soon, possibly the last powerful system of 2025, and this one carries a high ceiling for intensity depending on how conditions evolve. We'll break that down in today's video, along with a separate storm system crossing the lower 48 that could trigger strong winds and severe weather. We'll start with the newest run of the American GFS model, which was the first to detect this system. Now, other forecast models are joining in, showing growing agreement. As you can see here in the Caribbean, low pressure begins to develop within about a week, eventually becoming a named tropical storm. In this model run, it tracks toward Puerto Rico, while other model scenarios take it into the Gulf of Mexico or up the East Coast. There's still a lot to sort out, but this is a clear signal of development potential. So where is this disturbance now? It's currently in the main development region of the Atlantic, traveling alone across open waters. It's not well organized yet, but it has consistent convection and is maintaining strength. One thing I told you earlier this week was that it needs to survive the MDR and reach the Caribbean to have a real chance at organization. So far, that's exactly what it's doing, holding steady and maintaining thunderstorms, even if it hasn't become more structured just yet. There is dry air to the north of the system, along with some ahead of it, but a moist boundary associated with the ITCZ is helping protect it, keeping its environment moist enough for development. It also appears to have a well-defined marsupial pouch, meaning it has a tight core of moisture and vorticity that helps shield it from hostile conditions, a good sign for long-term survival. So while this isn't a tropical storm yet, it has the foundation to become one. Let's analyze the model projection timelines to see when development could take place and what track it may follow. Tropical development. Data starting again with a GFS model. None of the models show development before it reaches the Caribbean, which is good news for the Lesser Antilles initially. However, once it enters the Caribbean, nearly every model begins intensifying the system. We've talked about this possibility before. Around 5 to 7 days from now, the system slips into the central Caribbean, south of Hispaniola, gradually organizes, and by 7-10 days out, becomes a tropical storm and then a strong system, slamming into Hispaniola in this run before lifting toward the Bahamas and out to sea. Now, what does the European model, ECMWF, show? Nearly the same setup. It doesn't develop the system in the MDR, but brings it into the Caribbean early next week, Monday or Tuesday, where it encounters a more favorable environment for strengthening. I'll explain why conditions in the Caribbean are more favorable in just a moment. As this system continues to slowly organize, it is projected to achieve a name within the next 10 days or so, not this upcoming weekend, but the following one. From there, it steadily intensifies, evolving into a tropical storm, then a hurricane, before slamming into Cuba in this particular model run, though that's still 10-15 days out, deep into the long-range forecast. That's where the model data ends, with the system emerging near the Bahamas. So yes, it's still a long way off, but even the European model continues to develop this system, confirming there is real potential here. Let's take a look at a few other models. Canadian model, CMC. The Canadian model also pulls this disturbance into the Caribbean. Historically, this model has been a little too quick to develop storms, and once again, it tries to form this one before it reaches the Lesser Antilles. Personally, I'm not buying that solution. Even if it were to briefly organize earlier, it likely wouldn't strengthen much until it enters the Caribbean. Still, the CMC shows earlier development, then intensifies it into a strong tropical storm by early next week, before drifting toward Hispaniola in Jamaica, where it weakens slightly. ECMWF AI, Euro AI model. Now, let's examine the Euro AI model, which has actually outperformed some traditional guidance this season. Instead of rainfall, this model uses vorticity maps, measuring spin in the atmosphere. Brighter shades of orange, pink, and purple indicate increasing rotational energy and lower atmospheric pressure, a clear signal of tropical development. By Monday and Tuesday, the Euro AI shows organized spin forming south of Jamaica, but unlike the other models, it sends the system farther west, toward Central America, where it interacts with land before fully intensifying. Is that realistic? Absolutely. There's a well-known phenomenon in meteorology called the beta effect, which basically means tropical systems naturally drift westward more than models often predict. So, the Euro AI may be picking up on that westward bias correctly, or it could be overdoing it a bit. A more balanced solution might bring the storm a little farther west first, then allow it to curve northward later, which would increase potential impacts to the United States. So clearly, multiple scenarios are still on the table. But now let's examine why the Caribbean environment is much more favorable, and why this disturbance has a legitimate chance of becoming a strong storm or even a hurricane. Why the Caribbean is primed for tropical development. Deep tropical moisture forecast. Data shows a significant surge in atmospheric moisture across the Caribbean as this system arrives. These precipitable water anomalies show how humid the atmosphere is compared to normal. And green shading means high humidity, which fuels tropical cyclones. The European ensemble confirms abundant moisture from Central America eastward toward Puerto Rico about a week from now. Moisture will not be a limiting factor. In fact, the system itself may further moisten the environment as it organizes. Favorable upper level. Winds next. We look at wind shear and upper level winds. Early next week, models are showing signs of an upper level anticyclone, a pocket of divergent winds aloft that actually helps tropical systems strengthen. When winds spread outward at high altitudes, it creates a vacuum effect that forces air from the surface to rise and converge, lowering surface pressure and boosting storm development. This creates a vertical engine, one of the key ingredients for tropical intensification. Extremely warm ocean temperatures, but by far the biggest factor, and I've been saying this for over a month now, is the absolutely scorching sea surface temperatures in the Caribbean. The water isn't just warm at the surface, it's deep, high-octane heat energy extending well below the surface. That gives storms endless fuel to tap into. As tropical systems extract heat from the ocean, it condenses into thunderstorms, releasing tremendous amounts of latent heat, which intensifies the circulation even more. That release of latent heat lowers surface pressure even more, creating a self-sustaining feedback loop that rapidly intensifies tropical systems. The Caribbean is infamous for this type of explosive development. Low wind shear, deep tropical moisture, and extreme sea surface heat often align here. When those ingredients come together, the ceiling for storm intensity becomes extremely high. Now, does that automatically mean we're heading toward a Category 5 monster? No, absolutely not. There are still many variables we need to figure out. This system hasn't even officially formed yet. But if a well-defined circulation develops and the environment cooperates, then yes, the potential intensity is significant. So let's look at the ensemble data, which helps us understand possible storm tracks and future strength scenarios. European ensemble forecast. These are the European ensemble members over the next 10 days. And yes, there's a strong signal for development. One key thing to notice, many members cluster the system closer to Central America. That supports a later forming system, similar to what the Euro AI model indicated earlier. Those scenarios keep the disturbance moving west longer, delaying development until it nears Central America, then strengthening near land. However, another group of ensemble members, more aligned with the GFS and Canadian models, shows earlier development once the disturbance enters the Central Caribbean. These tracks take it toward Jamaica and Hispaniola, then begin to curve north. Here's why that matters. Early development plus early northward turn misses the U.S. mainland, except maybe Puerto Rico. Most likely recurves out to sea, delayed development, plus deeper western track. Greater threat to the Gulf of Mexico. Higher impact risk for western Cuba, Mexico, and U.S. Gulf Coast. GFS ensemble forecast. The GFS ensembles show the same two-track split. Camp 1 forms quickly, pulls north earlier, less U.S. risk. Camp 2, growing trend, forms later, tracks west longer, higher Gulf threat if that second camp verifies. We're looking at a potentially serious system for the lower 48, especially Florida or the central Gulf Coast. Definitely worth watching.